Hi, everybody. Good morning. It's Mr. Vallejo. Welcome to our science classes. And today we're going to be taking a look at dimensional analysis. All right. Here is a reminder for you to take your Cornell notes in this fashion. If you're doing on paper, please set your paper up like this, like we did in 2015 with physics. Or if you're doing this on the new Microsoft Word template, you can do it electronically on your template. You can also take that template and save it into your Google Drive, convert it to a Google Doc, and then use that Google Doc to take your Cornell notes. Remember to complete your notes after the end of this talk with 5 Cornell questions on the left and a summary at the bottom that starts with the phrase, in this lecture, comma, I learned. And so we'll be expecting that from you soon. I'm sure you're going to do a great job. We're going to take a look at dimensional analysis this morning. And dimensional analysis is, as you can see on the slide, used to convert from one unit to the desired unit. Okay. So sometimes a big unit won't be as appropriate as a much smaller unit. If I had a really small quantity of liquid, I might want to measure it in milliliters. But if I'm pumping gasoline, I don't want to know how many milliliters I have. I want to know how many liters I have. So in dimensional analysis, you convert from one unit to another unit to another unit to another unit, and just keep canceling out units until you get the unit that you need. So to start off, you need something called a conversion factor. Now, if you look at the first red bullet, you can see 1 kilogram equals 1,000 grams. Now, instead of writing them side by side with an equal sign right there, you can also write it in the form of a fraction. 1 kilogram over 1,000 grams, or the third red bullet, 1,000 grams over 1 kilogram. These are all the same thing. There are just 3 different ways to write this. So what is a conversion factor? A conversion factor is a simple ratio that relates 2 units that express a measurement of the same quantity. All right, so it's equal. On the first bullet, both the left and the right are equal. On the second bullet, the top and the bottom are equal. On the third bullet, the bottom and the top are equal. So these are equal. And as you know, when you have a fraction and you have the same thing on the top, and the same thing on the bottom, in other words, the top and the bottom are equal to each other, then when you have a fraction, you know that that fraction then will equal 1. Another thing you know is if you take any number and multiply it times 1, what do you get? And if you said you get that number, then you're absolutely right. That'll be important as we use the conversion factors to do dimensional analysis. All right, here's a simple one. Okay, here's a hand. You can flip them around because the top and the bottom are the same. So in my conversion factor for hands, I'm going to say 1 hand equals 5 fingers. I can also say 5 fingers equals 1 hand. Or I can say 1 hand over 5 fingers, or I can say 5 fingers over 1 hand. So these are all different conversion factors. But one of these 2 fractions at the bottom of the page, those are going to be the more useful way to write it. Because what we're going to do now is solve some dimensional analysis questions. And we're going to do this by using these steps. Step 1, identify the quantity and unit given. Like what are you starting with? What's the number you're starting with? And what's the unit you're starting with? And then figure out what unit you want to convert to. Like if I want to figure out how many milliliters is in 2.83 liters of gasoline, 2.83 liters of gasoline, well, that's 2,830 milliliters. So I know the number, the quantity. I know what I started with was 2.83 liters, and the unit that I want to convert it to, I was interested in how many milliliters that was. Now, I did that in my head, but you're going to see how I do this all drawn out so that you can show your work and be correct. And it says the second step is to set up the conversion factor to cancel the given unit. So what you do is you keep canceling and you keep putting other conversion factors in and put another conversion factor in and put another conversion factor in until you get what you want, until the unit that you want to convert to is what you get at the end. And then you don't have to really worry about the numbers till the end. I mean, you have to know what quantity you start with, but then at the end, you can multiply and divide all the quantities to figure out what the actual number might be. You'll see what that means in just a second. All right, so here's my scenario, and this is for all you soccer fans out here. If your whole soccer team of 11 players puts a hand in the middle and yells, defense, defense in other words, how many fingers were there in the circle? I just put mine in. All right, but there's 11 people all together. So you might be able to figure this out on your own in your head, hopefully. But let's use this as an example anyway. There are 11 players on the field, and this is what we call the given. So what's given is that there's 11 players. And here's what we know. We know that there's a conversion factor, okay? And we also want to identify what units we want to end up with. And in the question, it says, how many fingers were there in the circle? So we want to get the fingers by the time we're done. So we have 11 players, and we want to get the fingers. So let's do it. All right, so each player put one hand in. So the conversion factor is one hand over one player. Or you could also write it this way, one player over one hand. The question is, well, which one is it? Which one should I use? And I will tell you, because we're just learning this, that this first one is the one we should use. One hand over one player. Why? Because we want to have it in such a way that the player cancels out. We want to cancel what was given. So what was given again is that there are 11 players. And so our first conversion factor, going back, you can write as one hand over one player or one player over one hand. And so we're going to write one hand over one player. Because as you know, mathematically, you have the same thing on the top as you do on the bottom of a fraction. Those you can cancel out because they equal 1. So now we have hand. But if you remember, what we wanted to have our answer is, we want our answer in fingers. So I got to keep going. So I have players canceled out. So what do I know about hands? And is there any relation to fingers? And there is. We know that there's one hand equals 5 fingers. So we can make another conversion factor that looks like this. One hand over 5 fingers. Or it might be 5 fingers over one hand. One hand over 5 fingers or 5 fingers over one hand. Which one do I use? And hopefully you know that you're going to use this one. Well, why are we going to use that one? We're going to use that one because we need to cancel out the units that we have. Going back, remember that we ended up with hand because the players canceled out and we were at hand. So because we have hand on the top here, the next conversion factor, we're going to want to have hands on the bottom. So here's the hands on the bottom. All right, so we want to cancel that hand, and here's how we do it. We've already done this, but we need to cancel this hand right here. So the conversion factor is 5 fingers over one hand, and what we're going to do is cancel out hand now. And so we're left with fingers, which is what we wanted. So there are 11 players on the field, and each player put one hand in, and there are 5 fingers on a hand. These are all things we know. And so we start with what's given, and then we have used a couple of conversion factors. Here's one, here's the other. And so when we cancel all these things out, player, player, and hand, hand, then we get fingers. So as far as units go, we're set already. We got to fingers. But we got the fingers by canceling out player and canceling out hand. But we haven't done anything with the numbers yet. So what you have to do mathematically is you got to take the quantities and multiply the quantities that are in the numerator of these fractions and then divide it by the denominator. So in this case, it's going to be, after we cancel, we have 11 times 1 times 5. And on the top, it's 55. And you can probably see on the bottom, you've got 1 and 1. So you're going to multiply those top quantities and get 55, but then you would divide by any number at the bottom. In this case, it's 1. So any number divided by 1 is also that number. So we have 55 fingers. So we're multiplying all those quantities, and that's how we got the 55. I want to remind you, in physics especially, in chemistry also, in science, a good idea to box your answer, and you need to show your work. And so you've got to show your work by showing the cancellations like that. That's dimensional analysis. It's dimensional analysis a way to figure out a conversion and to use conversion factors to get from one unit to another. Also, it's a way that engineers use to check their work. If they start at the very beginning and they end up with the wrong units, and they know something went goofy, something went awry in their calculations, and that the signal will go back and check that out. So here's some other examples for those of you who are taking chemistry right now. This one comes from the chemistry book on page 15. A typical bacterium has a mass of about 2.0 pentagrams. That's one we hardly ever use. It's a really small quantity, expresses diameter in grams and kilograms. I'll get your question right after this, okay? All right, so you got 2.0 pentagrams. And you've got, there's the conversion factor. 1 pentagram is 1 times 10 to the negative 15th grams.
Yeah, I sent him like 2 messages.
Okay. And then what you got to do is cancel those out and get the unit that you want. But this says grams. We want to go to kilograms. So we've got to take this just a little bit more. And then we go grams to kilograms, 2.0 times 10 to the 15th, negative 15 grams. And you know also that there's 10 to the 3rd grams in a kilogram. So this could be upside down and backwards, reciprocal. But in this case, we're going to need to cancel out the grams. So we're going to cancel out the grams, and we get 2.0 times 10 to the negative 18th. Remember, it has units, and I boxed my work. So that's one example. Another example. On page 15, number 1, a human hair is approximately 50 microns, or micrometers in diameter, expresses diameter in meters. And so what you do is take what's given, put a conversion factor on there, cancel out the units, and then take the numbers and divide those numbers. So 50 divided by a million is 0.00005 meters. But you already know how to write this in scientific notation, and so that can be expressed that way. All right. So if you don't remember scientific notation, please go back and take a look at the video on scientific notation for a review. Okay. So we have some questions.